3 days. That's all that separates 3I/Atlas from a solar bombardment so intense. 33 billion tons of alien ice, rock, and metal hit by 33 gigawatts of raw sunlight. It could explode, split apart, or do something science has never seen. Right now, it's completely vanished, hidden behind the sun, while astronomers wait, blind, for whatever will emerge. What happens next could rewrite our understanding of interstellar objects forever. But why does the cosmos suddenly seem so much stranger? And why are the world's top space agencies acting like there's something they're not telling us? Atlas is now lost behind the sun, invisible to every telescope on Earth. For astronomers, this blackout is more than a simple inconvenience. It's a total sensory deprivation, a forced pause at the very moment when the most extreme changes might be happening. The geometry is unforgiving, with Atlas nearly in line with the sun as seen from Earth. Even the most powerful observatories are blinded by solar glare. No ground-based telescope, no Hubble, not even the James Webb can safely point in its direction. The blackout window stretches for weeks, leaving only a handful of deep space probes with a chance at a sideways glimpse. While the world waits in the dark, Atlas is about to endure a solar onslaught. At perihelion, just 1.4 astronomical units from the sun, this interstellar visitor will absorb an energy blast measured in gigawatts. Estimates range from 1 to nearly 19 gigawatts, depending on its true size and reflectivity. That's comparable to the output of a dozen nuclear power plants, all focused on a single, tumbling chunk of alien rock and ice. The surface temperature is expected to soar. Intense thermal stress could fracture the nucleus, trigger violent outgassing, or even cause the object to split apart entirely. The blackout means no one will witness these changes in real time. Scientists can only calculate probabilities, run simulations, and wait for the first post-conjunction images to reveal what survived and what didn't. The suspense is amplified by the knowledge that any sudden fragmentation, outburst, or unexplained motion will be invisible until Atlas re-emerges. With every hour, the sense of anticipation grows. The clock is ticking, the object is hidden, and the next data point could upend everything we think we know about interstellar visitors. Atlas doesn't just arrive from the void. It threads the solar system on a razor's edge. Its orbit slices through the ecliptic at a steep retrograde angle, nearly a mirror image of the planetary paths. The inclination clocks in at about 175 degrees, placing Atlas within just 5 degrees of the ecliptic plane, the same narrow band where Earth, Mars, and Jupiter circle the Sun. That kind of alignment is astonishing for an interstellar object. Odds of a random visitor from another star system matching the solar system's orbital plane so closely are less than 1 in 500. Most interstellar comets shoot through at wild angles, their paths dictated by cosmic chance, not geometry. But Atlas travels as if it's following a carefully plotted route, gliding almost perfectly along the solar system's invisible highway, but in reverse. This geometry isn't just a mathematical curiosity. It means Atlas passes through the heart of the planetary neighborhood, maximizing the number of close encounters with major worlds. The trajectory brings it near Venus, Mars, and Jupiter, all without any dangerous approaches to Earth. For planetary scientists and defense planners, this raises unsettling questions. Is Atlas simply the product of cosmic coincidence, or does its path hint at something more deliberate? The encounter geometry alone has fueled debate among astronomers, with some arguing that such precision is nearly impossible without guidance. Others insist it's just a spectacular fluke, the universe dealing a hand so rare it almost feels intentional. Either way, Atlas's razor-thin alignment amplifies the stakes. Every calculation, every simulation, carries the weight of that improbable path. And as the blackout drags on, the question lingers: what are the odds that something so rare could be just an accident? But compared to Atlas's chemical secrets, even this orbital perfection is just the beginning. Atlas is more than just a rare visitor. It's a chemical puzzle wrapped in a mountain of metal and ice. Spectroscopic surveys have revealed a signature that doesn't fit any known comet. Instead of the familiar fingerprints of water and dust, Atlas glows with the unmistakable emission of nickel vapor, specifically nickel carbonyl, a molecule that forms only under exotic conditions. In laboratory experiments, nickel carbonyl appears when pure nickel grains are exposed to a flood of carbon monoxide at frigid temperatures, just above absolute zero. But in the wild, such chemistry is almost unheard of. Most comets carry some metals, but never in this form, and never with so little water. Atlas's water content barely reaches 4%, far below the norm. For comparison, even the famously odd comet 2E Borisov, another interstellar traveler, carried at least 5 times more water and showed both iron and nickel in its tail. Atlas offers only nickel, no iron, and a cocktail dominated by carbon dioxide. The numbers tell an even stranger story. Atlas weighs in at an estimated 33 billion tons, an order of magnitude heavier than any interstellar object previously observed. That's enough mass to dwarf the entire human-built satellite fleet, or to outclass most asteroids that cross Earth's path. To move something that massive on a hyperbolic trajectory, slicing through the solar system at high speed, takes either a spectacular cosmic accident or a process we don't yet understand. The combination of rare chemistry and sheer scale has forced scientists to reconsider what's possible in the cold, dark reaches between stars. Atlas is not just a curiosity, it's a challenge to every model of how comets form, evolve, and survive the journey across interstellar space. But the true shock comes from the way Atlas behaves, not just what it's made of.
Atlas didn't just break the rules, it seemed to ignore them. Instead of trailing away from the sun, its anti-tail pointed straight toward it, a narrow sunward spike that left astronomers unsettled. This wasn't a trick of the light. Pan-stars, amateur telescopes, and observatories worldwide confirmed the same improbable geometry as Earth's view crossed the comet's orbital plane. The anti-tail's brightness and persistence didn't fit the standard models. Dust grains large enough to create such a feature should have dispersed, yet the structure held, visible even as blackout protocols tightened. Inside NASA, the Planetary Defense Coordination Office went on alert. Though Atlas posed no threat to Earth, the combination of its trajectory, mass, and the unexplained anti-tail triggered a rare protocol review. Internal memos, later released through Freedom of Information Act requests, show staff divided. Some pushed for transparency, worried about public trust. Others insisted the anti-tail was a projection effect, dust from a past outburst, now caught in the right light. But the numbers didn't add up, and the debate grew tense. NASA quietly withheld high-resolution images from the Mars Reconnaissance Orbiter, citing data verification. Off-record, staff hinted at concern over what the images might reveal. Meanwhile, the European Space Agency released limited data from Mars Express and Solar Orbiter, confirming the anti-tail but offering little interpretation. The anti-tail became a fault line, exposing cracks in institutional confidence. Was Atlas just another comet, or something stranger? With blackout deepening, the sense of control slipped further away, leaving only questions and the promise of a coming scientific fight. Inside the world's observatories and online forums, the Atlas debate splits sharply along a single line. Is this a natural comet shaped by alien chemistry, or could it be a piece of technology, an artifact, not an accident? Avi Loeb, the Harvard astrophysicist known for championing the artificial origin hypothesis, points to Atlas's near-perfect orbital alignment, its pure nickel vapor, and the anti-tail as possible signatures of deliberate design.
He argues that if a civilization wanted to send a probe through the solar system, it might choose a trajectory that maximizes planetary flybys while avoiding direct collision, exactly what Atlas appears to do. Mainstream scientists, meanwhile, urge caution. They highlight how rare chemistry can arise in exotic, water-poor regions of protoplanetary disks, and how projection effects can explain even the strangest anti-tail. The divide is more than academic. It's a contest between radical possibility and rigorous skepticism, with reputations and scientific norms on the line. Both sides agree on one thing: only hard data, not theory, will settle the question. Until Atlas re-emerges, the mystery is as much about human imagination as it is about cosmic evidence. Every eye in the mission control rooms is now fixed on the calendar. The first shot at clarity comes November 4th, when the European Space Agency's JUICE probe sweeps past Atlas's projected path. Engineers have scheduled a rapid-fire sequence, hundreds of images and spectra, each frame measured to within a few dozen milliseconds. That's enough precision to catch even a subtle course deviation, a nudge as small as 10 millionths of a meter per second squared. If Atlas accelerates or fragments, the JUICE cameras will see it. Next, December 19th brings Atlas's closest approach to Earth, and with it, the full power of the James Webb Space Telescope. The James Webb Space Telescope's detectors can pick out faint debris, trace the coma's shape, and map the object's position against the stars with staggering accuracy. Across all these windows, the criteria are simple: any non-gravitational acceleration, any out-of-place motion, or a sudden breakup. These are the signals that would force a rewrite of the textbooks. The teams have their thresholds set, their algorithms primed. Now, they wait for Atlas to reappear and reveal its hand. On October 29th, 3I/Atlas will endure more than 33 gigawatts of solar radiation at perihelion, while the world's telescopes are blinded by conjunction. Atlas's orbit, within just 5 degrees of the ecliptic, defies the odds for any known interstellar object. Its nickel-rich emissions, extreme mass, and anti-tail have triggered rare planetary defense protocols and led to withheld NASA images, as documented in official agency memos. Despite extensive data collection and debate, scientists remain split. Some view Atlas as a natural but exotic comet. Others argue for artificial origins. Still, no released evidence explains the combination of a retrograde, near-ecliptic trajectory and its chemical anomalies. The next decisive test arrives on November 4th, as the European Space Agency's JUICE probe attempts a close flyby. Until then, key questions about Atlas's true nature, behavior, and origins remain unanswered. For now, the facts confirm only this: 3I/Atlas challenges every expectation of how interstellar objects behave and what might be possible in our universe.